Today, we're diving into something that's a genuine leap forward in how we keep our digital lives safe. We're not talking about just another checklist. We're talking about giving our software a brain of its own, to watch its own back. And it's all thanks to some incredible new research.
And this isn't just a random idea. This groundbreaking work is coming straight from the University of Oxford's Department of Computer Science. These researchers are fundamentally challenging how we think about the security of our software supply chain. So let's just start with a question that sounds simple, but is actually pretty unsettling when you think about it. What's really hiding inside the software you use every single day? On your computer, on your phone, everywhere? In that question, well, it leads us directly to the hidden dangers that are lurking just beneath the surface. It's a way more complicated world than most people ever see.
You know, you have to think of any modern app less like a solid object and more like a massive skyscraper. It's built using countless different components, libraries, and little bits of code from developers all over the globe. Each one is like a different contractor putting in the windows or wiring the electricity.
Now, here's where it gets risky. All it takes is one single weak component, one faulty beam in that whole skyscraper to put the entire building at risk. And this isn't theoretical. We just saw a chilling real-world example with the attempt to sneak a backdoor into the XZ library. It shows you exactly where the bad guys are looking now, not at the front door, but deep inside these hidden dependencies. Okay, so to deal with this, the industry came up with what you could call an ingredients list for software. But as you're about to see, that list has a huge problem. This list is officially called an SBOM, which stands for a Software Bill of Materials. It's basically a formal machine-readable inventory of every single component that makes up a piece of software. It's all about creating transparency. So this is what an SBOM looks like conceptually. It lists out all the components, the metadata. It's super detailed. But here is the critical point. It's a static list. It tells you what ingredients are in the box, but it has no idea how or even if they're actually used in the final recipe. And that brings us to the core flaw, which the Oxford research states perfectly. A vulnerability associated with a software component is not necessarily exploitable, right? Just because an ingredient in a giant pantry could be bad doesn't mean it actually ends up in the final dish. So just how many of these warnings are basically useless noise? Well, according to the research, it's a jaw-dropping 95%. Let that sink in. 95% of the potential threats in SBOM flags aren't actually real threats in the real world. This creates an absolute nightmare for security teams called alert fatigue. They're just drowning in false alarms, wasting all their time and energy chasing ghosts while the real fires might be burning. So if a static list is broken, what's the answer? Well, this is where things get really interesting. The solution the researchers came up with is, essentially, about giving software a brain. This is the big evolution, from the SBOM to the Agentic AIBOM of materials, removing from a static ingredients list to a live, active monitoring system. It stops asking what's in the software and starts asking how is the software being used right now. This is how it assesses actual threats, not just a list of potential ones. The tech that makes this possible is called Agentic AI. And let's be clear, this is not the kind of AI that writes poetry. Think of these as tiny autonomous security guards. They can perceive what's happening around them and make decisions based on a very strict set of rules and policies. The best way to get it is with this analogy. An SBM, the old way, is like a recipe card that just lists the ingredients. An AI bomb, the new way, is like having a master chef watching over your shoulder, seeing exactly which ingredients you use and how you use them. So how does the system actually work its magic? Well, let's meet the 3 key agents that make up this intelligent security team. First up, before anything even runs, you've got the architect. It scans the whole environment and builds a complete baseline map. Then, once the software is running, the watcher jumps into action. It's a live monitor watching for any new components that get loaded, and, this is crucial, it watches which specific lines of code are actually executed. And finally, the judge comes in. It takes all the data from the other 2, checks it against the security policies, and makes the smart call. Is this a real threat, or is it just noise? And all this teamwork between the agents, it leads to a much smarter, much more effective way of doing security, which ultimately means safer software for everybody. And the output it gives is so much more useful. Instead of just a screaming yes or no alarm, the ABI bomb gives you a nuanced verdict. It can tell you if a system is not affected because the dodgy code was never even run, or maybe it was affected, but another safeguard was in place that mitigated the risk. This is the kind of intelligence security teams actually need. And this chart just says it all, doesn't it? On the left, the old way, a huge mountain of potential threats, mostly noise. On the right, the ABOM cuts through all that clutter and gives you a small, manageable handful of actual, actionable threats. So what's the big takeaway for all of us? It means security teams waste less time, which means they can patch real threats much faster. And that means we all get more reliable, more trustworthy software. It's just a more secure digital world for everybody. The researchers themselves summed it up perfectly. This isn't just a clever trick. They're establishing a whole new foundation for the next generation of software security, a foundation that's actually provable and auditable. And that leaves us with a really exciting question for the future, right? We're moving from static defenses to living ones. So if our software can now actively take part in its own defense by understanding context, what does that unlock? What's the next frontier for our digital safety?